Good morning. Some time ago, a couple of years ago, in a setting not much unlike yesterday in the Hemingway bar, sitting with a couple of friends over a couple of beers, just enough intoxicated that all the world problems seems very solvable, and you are just wondering why they are not solved already. One of the people present asked a question. He said, I don't understand one thing. How come companies that operate in a digital world, that their products and services are digital ones, so not tangible ones? I can download them, but I cannot, take them in my hand or do something else with them. And on top, their services are free. Millions or billions of users and no one pays them anything. How come those companies are the most valuable ones globally? What are they doing? Where's the catch? Okay, the setting was such that we, of course, found an immediate answer. Oh, it's smart advertising and so on, and the conversation went on. But the question stuck with me. I am rarely satisfied with the simple answers, because usually they are not the real ones. So the journey began, just at least for me personally, to find out what the hell is going on and how I can replicate that. And as soon as I Googled the first word, and I Googled it for free, came up, yes, data is the new oil. So obviously, if you have data, then you're automatically or almost automatically rich. I come from energy business, and what we do for the last 150 years is nothing but record data. So how come we are not rich? So there must be much more than that. One funny quote is, if we take this analogy further about the data and the oil, obviously we need an engine. We need something to burn this oil, to burn this data, and make something valuable out of it. So in my view, we are talking about three ingredients. We are talking about data sources and data availability. We are talking about capabilities of getting this data, making them visible, and making them available for in my opinion, one of the most important things, algorithms. These things need to be interconnected somehow. But again, it's a little bit more complicated than that. It's not trivial how you connect those dots. You need three a little bit different, it turns out, sets of systems. You need systems of records. Again, data sources, data that are stored, data that are in some sort of landing zones available for something. Then you need systems of intelligence. You need tools that convert this data into useful, actionable information. And information without systems that can act on it and do something with it are useless. And here, actually, when you act on it, the value gets created. But there is one more thing. The loop needs to be closed. And this is the makings of the winning combination. As in the real world also, it turns out that also in the digital world, there are some laws of physics that still apply. Namely, each action produces reaction. Each activity, each decision, each business decision that you make produces some reaction, and at the same time, the environment changes a little bit. If you're able to detect, to ingest, to record these changes, these feedbacks, enrich your data sets, expose these richer data sets to hopefully learning algorithms, you get better decisions. And you test them right away through your systems of engagement. And the cycle is closed. It just rinse and repeat. Or is it? There are two properties of this engine that we have come up with. One is that in the relationship with data value and the data quantity, where I don't mean just the sheer quantity, also the scope. So the variety of sources that you can correlate together is something like that. And of course, the most interesting is the breaking point. So the question would be, where is that breaking point? It's quite a lot of data. That's something that gets missed. Hence, the first word of today's presentation and the first word of our mission of my company in quest for getting value from the data. We want everything. We want to be able to record everything relevant to our cases. And the second property of this engine is you need to spin it. And you need to spin it fast. And we've heard yesterday on the keynote session from Mark, we want to make the frequency as high as possible of trying out, adapting, changing, trying out again. So hence the second word of our presentation. We want the data as they appear immediately, not the next day, not after some batch processes get completed over the night. No. As they appear. So we can act on them, feed them into our engine, and try to get something out of it as soon as possible. Those two properties are quite demanding. Actually, you need a proper environment to do this. And if I would be in the weather forecasting, I would say that the future looks really, really cloudy. This is the setup that we are aiming for at our company. Of course, products and services could be in the cloud with no problem, but in our case, they will not be at the beginning. But at least ingesting data, storing them, and working with them using services, the cloud is the only solution, the only option. And that's why, if you remember also that graph of value of stocks of Amazon that I showed, the shape and the timeline is very similar to other giants in the field. It all goes up after 2000s. Why? Because of the rise of cloud computing. That's the simple reason. The concepts are old, but the capabilities are new. How could we use this at my company? So, in order to understand that, I will spend a minute or two to explain what we do actually at my company. There are three phases that GenAI has, three sets of businesses. One is energy trading. We trade with electricity and gas on 22, 23 markets, from Turkey, Iran, towards North Cap, from Ukraine, Georgia, Russia, towards UK. So we cover the entire European continent. Second thing we do, or second set of businesses, is energy sales or energy supply. We supply end customers, from largest B2B to the smallest B2C customers. Our home market is Slovenian market, where we are the biggest ones, but also we are present here in Croatia and in Austria. And we are expanding a lot. The second set of businesses are so-called green services. This is one mission that we developed a couple of years ago, and we see it as our contribution to the changes, to the global changes in the environment, to the global warming issues and challenges. So our mission or our statement is that we, first of all, will make everything run on electricity, and then, or at the same time, we will clean up the sources of electricity. We believe that this is the only or the most feasible way forward into dealing with climate change. One of the most important or most popular green services, just to give you a little bit more concrete picture, is photovoltaics. We provide photovoltaic power plants for people to put them on their roof. But in the GenAI's fashion, this is not an online store, it's a package. Our motto is we take care of everything. So we take care of paperwork, we install it, we monitor it, we maintain it, and we give you guarantee of your savings and your profit actually at the end of the day. If you look at those three businesses from another perspective, you could see that we are in the forecasting business. We are digital. We were digital from day one. Because electricity, you cannot hold it, you cannot touch it, or you can, but it has some side effects. So it's basically like information. It's virtual. It's there, but you don't see it. So with forecasting in trading, it's simple to understand, I think. We are forecasting where the prices will go. If our forecasts are good, then we position ourselves right, we make millions. If they're not good, we lose millions. It's simple as that. We do our forecasting based on weather data, on weather forecasts, on outage data, on load forecasts, so what the consumption will be, and other things. A lot of things to consider. In the sales business, we do load forecasting for our customers because electricity, again, has one very interesting property: it cannot be stored. You need to buy it as much as your customers will use it at the same time. Of course, there are batteries, but I'm talking about meaningful storage, not just for your phones. So, hence, you need to forecast what your customers will use in the future period. And you need to do it without asking them. Again, a lot of data goes in to do this right. If we do this wrong, we get punished, we get fined. This is how the system works. Another more interesting set of forecasts is customer lifetime value forecast. Based on your past activities as our customers, we forecast what you'll do in the future, and we calculate your entire value for us. It might be good, it might be not good, and in the future, for sure, it will more and more dictate how we behave towards you, whether we love you or love you a little less. And on the green services field, first of all, is cross and upsell opportunities. You're already a customer, and I know a lot about you just by looking at your energy consumption. And I can detect when and whether you are a good candidate for a power plant or for an electric car, perhaps, because I know much more about you than you might think. As I said, we do things in a genuine way, which is we take care of everything. So when we are entering with these services, these kind of services in the real world, then we have some assets that we need to take care of. Not a small number of assets. For example, just last year we installed, or till now we have installed more than 1,000 power plants that are all IoT devices connected to our monitoring systems through some sort of cloud infrastructure. And preventive maintenance, forecasting when something will fail, is very important. It's very cost saving, but also gives this quality of service that we strive for. We will come to your house and repair it before you will even notice that something is wrong. That's what we are all about. So a lot of forecasting, a lot of data. Let me show you, to conclude this part, one new service that we are developing. We are testing it actually in-house at the moment, and try to see how this concept works. And we already use it. The concept is not something new. So, in the field of electric cars, one thing that is very interesting to look at is how you charge your car. First of all, cars are very huge consumers of electricity, more than we actually are aware at the moment. And through this example, let's see that the bottom line is a typical household or a small business consumption during the day. More during the day, less during the night. It's simple, it's logical. When one car comes into play, then the consumption turns into this light blue line. And 10 p.m. is, at least in Slovenia, is the start of the low tariff, so cheaper electricity, so car gets connected at 10 and it spikes. Cool, nothing wrong with that, just you need to wait for the 10 p.m. if you want the cheaper electricity, but it's not more than that. But since electric cars are so cool, and I've never known anyone who drove it and then switched back to the regular car, it's a matter of time when your wife, your husband, your coworker will want also his or hers electric car. And then you have a little bit of a problem. Because although cars are very smart devices, are also extremely stupid when it comes to charging. Or not stupid, selfish. When car gets connected to the plug, its mission is to get charged as soon as possible. And it will take from the plug whatever it can take, disregarding any limitation and not being aware that there's a car with the same mission sitting right next to it. and that they're both fighting for the same limited energy. The red line, for this example, presents the limit. These are your fuses. So if you connect both of them at 10 p.m. like you're used to, you will most probably blow out your fuses and your house or your place of work will go dark. There are two ways how to solve this problem. One is increase connection power. Sure, first of all, it costs money, and second of all, it's not infinite. Sooner or later, someone from the power company will tell you it does not go any higher. Okay, what do I do when I have this situation then? This is an actual photo from our garage in Ljubljana. Yes, we are fans of Teslas. What do I do then? You can get a little bit smarter with charging. So here is the service that we are developing. What we have is actually smart meters that meter the consumption of the entire site. What we have, smart plugs or charging station, you name it, whatever you want. These are devices that are, of course, all connected. And these smart plugs perform two functions. First of all, they tell us whether the car is plugged in or not, and they tell us how much energy that car would require to be full. It tells us much, much more. You would be amazed how many data, how much information you get from your car when it gets plugged in. Serial number, type of car, year of production, you get tons of data. Okay? These are our systems of engagement that we can work with. Of course, they are all connected. We measure everything. We import everything into some sort of platform, landing zone, where we can work with, and we can combine it also with some other data, and we apply algorithms. That algorithms serve two functions. They need to predict when you will need the full car, how will the consumption of the rest of the building go, and it's all done based on your past usage cases, on the past patterns that we detected. We are not asking you anything. And through this, we control how the cars, in plural, get charged. With aim that they are all charged in the morning, if this is the use case. At 7 a.m. when you leave for work, you and your wife, they both need to be fully charged. The result is something like this. You could do this manually. You set your clock at 1 a.m., you wake up, you unplug first car, plug the second one, and it works. Or you can get our service, and we do this for you without ever asking you anything. We just guarantee you that your car will be full in the morning. This is one very simple example. It is a little bit more complicated than that, but the principle is just that I've said. And this is just one example how this loop of constantly improving, learning about your habits. If you change, you buy a third car, I will, through the loop, detect it. I will adapt. And that's the whole point of the game, and that's the holy grail that we are looking for, and this is the value we see in the data that we sit on. Obviously, as I said in the beginning, we are not the first one to come up or to understand this concept of everything now. It looks like there were some artists in the past who understood this very well and confirmed our theory. Unfortunately, it was before the cloud, so Mr. Mercury had no choice but to sing about it, and that's all he could do about it. But he was right. He was totally right. One thing that I really like being a manager, it is that I get to think about such concepts, I get to study them, I get to talk about them, I get to show nice presentations, and the best thing is that I have other people who then need to build it and deliver. And so with this, I would like to invite to the stage my colleague, Chief Digital Officer, David Vidmar, who will hopefully explain to us and to me how we will explode the value of GenAI and make us all rich. Thank you.
Thanks, Andrej. Thanks for the word and thanks for the challenge. And it turns out it's more than one band, more than one singer singing about it. This is Arcade Fire album, Everything Now. So it's a nice goal. It's a high goal. We like it, and it's only one thing left until we're done, so somebody needs to build it, like Andrej said. So let's dive a little bit deeper how the process of thinking about it, how creating a vision, how to build it started and where we are now. First, let's define what everything means when it comes to GenAI. Obviously, there's tons of data, like Andrej explained, but which data is that, right? So we know that we have a lot of data. We run ERPs, we run CRM systems, we run trading systems. These are all classic on-prem systems running on SQL Server with tons of data in there. We have our own data warehouses. We have our own storage for data series data. Majority of our data is actually data series, so all weather forecasts, all information where all tankers are, or our predictions and model results. So this is the known part. Then there's a ton of data, possibly more than data we know where it is, that sits on our analysts' computers in some random databases in undocumented tables. It is production data, but it's not very well documented. So we know we have data, we know it's somewhere, but it's not always easy to find. And of course, there's tons of data more that we could have. So all of our power plants are pumping enormous amount of data, cars, heat pumps, customers clicking on our websites, data we today do not collect, or we collect some, but there is a lot more that we could. So it turns out that there's one more dimension to the data. So our analysts, by the last count, we have 65 people that have analyst in their job description, writing Python algorithms, doing various prediction models and so on. And they like to play with data. Sometimes they destroy the data. So we need more than one copy of the data. We need a system to quickly replicate, duplicate the data sets so they can experiment with the data. It turns out that everything really is everything. We want everything. So there's no limit to the amount of data that we want to store. That's pretty simple. But what's the definition of now? This is where it gets a little bit complicated. If you're an analyst, or even if you're an end user, it could mean, do I want it really fast? Do I want it now, once? Do I need real-time refresh of my model? Do I need it once per day? Do I need it in 1 minute, in 1 second? Who knows? Who's the one that can tell us what now means? It turns out that the user of the data, end user or the analyst, and it really is not about time, is whenever they need it. So it's on demand, it's self-service. And this is the first challenge that we encountered. We need to be varying requests for data. So our models could be refreshed once per day. If it's a slow week when trading energy, once per week is okay. But there are days that if we can do it 20 times per day, we can earn more money than we do now. So it really is whenever it's needed. Once we covered that, we said, yeah, so let's just buy some software, put it out there, and the problem is solved, right? So this is a typical IT project. Just call some vendors, they will tell you what you need. Well, we were a little bit smarter than that, of course. We started talking with analysts, with IT architecture, with our big data experts, what's the problem that you have? And the first problem we encountered, we do not have a problem. We don't have a problem that needs solving now. So our predictions happen, we earn money, we can store all the data that we actually need. So we are creating a problem that we want to solve. So obviously this is not then an IT project, it's more than that. So we didn't plan it, we started somewhere else. We consolidated what we heard, and we tried not to solve a particular problem, but we wanted to zoom out as far out as possible. So what are the 4 things that everybody told us? They want user-friendly access. They want to quickly find the data, quickly access data, quickly replicate data in their own data store so they can work on that. That's pretty obvious. We all like friendly user experience, nice UI, and so on. So that's basically that. So everybody told us, yeah, we don't want data silos. We want data in the same place. Well, maybe 10 years ago, Oracle was trying to sell something like that. Microsoft was trying to sell something like that. It does not work like that. So we cannot have data that Tesla cars are putting out have in the same place as our ERP data, because that data is streaming live. It's stored in the other cloud. We cannot talk to Tesla. We can only talk to Tesla cloud. It's the same with the power plants. It's the same with heat pumps and so on. So yeah, there are data silos. There will be more than one. There will be more and more, but we want to consolidate them in virtual manner. The important part was also the single source of truth. Okay, we understand that the same data is replicated in the different places, but we need to be able to define where is the source, where is the definite source of the data. And the last one, when we optimize our algorithms, when we train our models, we need to be able to replicate what we did 2 years ago. If you do not have nicely collected data, this thing can quickly fall apart, right? So then what are we benchmarking against? We don't know how we come to that result. How do we know this year's is better than the last one? So these were the 4 challenges that we started to solve. And we started a project. We gave it a name. It's a modern analytics platform. It got an acronym MAPL. It's stuck. We set up a cross-functional team. Amazon would call it 2-pizza team. But in Slovenia, we like to eat a lot, so that would mean 2 persons. But it's more than that. We have, we have 4 people from different companies that all are challenge solvers, that all are super passionate about this, and the 4 of us are driving this thing. Then is a bigger team of, let's say, 8 to 10 people that are working on pilot projects and so on, but the core is a cross-functional 2-pizza team. We created a simple diagram that explains the vision. It's easy to explain, it's easy to talk about. It does not talk only about the challenge, but is proposing a solution. So that was the crucial point. And yeah, we showed it to everybody, refined it, and came to some agreement. Yeah, this might work. Yeah, these are actually the challenges, and these are actually the possible solutions for that challenge. But more questions rose from that. You know, it turns out that we already have that. Not one, but we found 3 similar platforms in 3 different departments in the company. First, let's consolidate what we're trying to do and have just one platform. Otherwise, Sandy will have one, Lev will have one, and so on. But let's build a common platform. We have 2 data centers, one in Ljubljana, one in Nova Gorica. We have tons of hardware, we have tons of software, we have people that really are good with running those. So we can have that on-prem. There's no issue. We just buy a lot of disk, a lot of CPU, and we are good to go. Or do we go to the cloud? Do we trust the cloud with our most important assets, which are not the data, but our algorithms, our prediction models? Do we trust that it will be always on? That if we do not do some of our predictions in time, we get penalized super heavily. So we are really a real-time company. And it turns out, yeah, we want to go to the cloud. The reason is elasticity, and the second reason is because we want to use the best technology there is. And currently, everything happens in the cloud. And the last part, do we buy it or do we build it? Because there's a ton of offering in analytics platforms for energy companies. There are at least 5 to 10 companies in the world offering just that. It turns out that we are not typical, that we do not own the grid, we do not operate the grid, we do not own the smart meters, and there's a huge problem with smart meters that all of those platforms are trying to solve, but we are not currently solving that problem. So we decided to build it because it's not specific to energy sector in any way. We could be selling cars, we could be selling, I don't know, shoes, but we are selling megawatts of energy. And there's one more thing, if we'll build it, we will use it. So we don't want to buy it, we don't want to rent 20 developers and to build it. We want to be the experts in what we have. We don't want a black box. If we build it, we love it. So we are doing a heavy internal promotion of what we're trying to do, and actually there are stickers of the Maple. Now you know why the Maple name is so cool. And our KPI is when all the analysts will have those stickers on their laptops next to the AWS and Azure and GitHub stickers, then we have their hearts. And if you have their hearts, they will be using it. And we do not aim to build it in a big bang. So we'll start lean. We'll build the smallest possible platform that we need, and be agile about it, where we're going with it. And of course, we will use only the best ingredients. Every cook will tell you that this is the most important part of the recipe. Use the best ingredient that you can afford. So this is our reference architecture being evolved with EOLab guys, being evolved with Microsoft, being influenced by Gartner and tons of people. Super simple. Again, we have internal, external sources running that in data lake through several layers of data lake. We want to give our data science people a sandbox where they play, where they can publish their solutions, and we want to have a curated storage that stores data in the most appropriate format for that particular type of data. For our end users, nothing really changes, except they have this self-service capability. They can run their own models. They can change the parameters. They don't have to call an analyst at 4 o'clock. Yeah, I need this one more simulation because there's a deal out there. But then the analyst is there until 7, but the trader changed his mind and went to beer, because this happens, right? And of course, no business presentation is complete without an iceberg, right? Every presentation needs a picture of the iceberg. Yeah, technology is that what we see, what we fear, but there's a scarier part underneath. And what's that scarier part? Is we need to reorganize ourselves. Who does what? What's IT? What's analytics? Who's the architect of data models? Who's deciding what gets curated, what doesn't get? So it's the whole organization thing, and everybody needs to agree. If not, we have a problem, right? So if we have a lot of data, we need to be smart. Who's accessing it? How do we find it? How do we build the virtual models? How do we catalog it? And so on. So the whole data governance team is being set up as we speak. Of course, if we want to build things faster, be agile about it, there's no way around it. We need to use DevOps as much as possible. We do use it now. We need to be even better with it. And this is what's under the sea. So the final thought is, why don't everybody have something like that? What's so difficult about it, right? Is it expensive? Is it complicated? Is it not secure? What's the reason that the people we are talking to don't have something like that? My theory is not about technology. It's about people. It's about what's under the sea. And Kai-Fu Lee, if you read the AI Superpowers, has put it like that. There are 4 ingredients why China is so big in AI and US is so big in AI and nobody else is coming close. You need abundant data. You need crazy entrepreneurs that just do not respect anything that happened before, just building new stuff. You need scientists. You need people that know how to do models, predictions, turn around the data, and you need the policy environment. And this is exactly what we've been hearing when we were talking to vendors and companies trying to build something like that. Yeah. First, of course, you need the management support. If you don't have the money, you don't have the resources, you cannot build something like that. Then you need the data. And this is not the data we started collecting last month. No, you need 10 years or 15 years worth of data if you want to do any sensible predictions. You need data scientists, and I hear that a lot. People say, yeah, we want to be going into the machine learning, we want to do the AI stuff, but we cannot hire data scientists. You need to have a great challenge, you need to be able to pay them, and you need to be able to hire them. And this seems to be the problem. And at the end, and possibly the most crucial thing, you need to have a problem to solve. You need to have the questions. I've heard so many times that people say, yeah, we hired people, we have the data, we build the models, we have the predictions, now we're running around the company and showing the report and the dashboard to head of sales, and he says, yeah, but I don't need that. You know, I've been doing this for 10 years on my own and it worked great, so why are you showing me this. And I'm super excited to work on this project because GenAI has everything. Like I said, we have 65 analysts. We have data going back to the beginning, that's 14 years ago, right? We have full support from Andrej and the whole management team, and we do have questions that our management and directors are asking. They're asking to be data-driven company, and this is the ultimate goal, being a data-driven company. So thanks. This is it.